Welcome to the Explainer. Today we're diving into something that works like a silent guardian for your entire digital life, something you use all the time without even realizing it. We're talking about encryption. It's the magic that keeps your private stuff, well, private. So let's break down how it all works. So let me just start with a question for you. When you're online, sending a message, checking your bank account, typing in a password, is all that information just an open book for anyone to snoop on?
The kind of scary answer is, yeah, pretty much. Without something protecting it, every single piece of that sensitive data would be completely out in the open.
And that right there is the fundamental challenge of living our lives online. I mean, our most private information is constantly flying across the globe through networks and servers we'll never see. Just think about your day-to-day, your passwords, those private messages, your banking info, even the photos you back up to the cloud. All of that is just digital information on the move. And if it's not protected, it is incredibly vulnerable. So how do we protect it? Well, the answer is encryption. And honestly, the best way to think about it is as a digital lock and key. Here's the basic rundown. You start with what's called plain text. That's just your normal readable message. Then the encryption process kicks in and scrambles it all up into ciphertext, which to you or me would look like total gibberish. So what encryption is really doing is turning perfectly understandable info into what looks like complete nonsense. But, and this is the important part, it does it in a very precise, mathematical way so that the whole process can be reversed, but only if you have the secret. And that secret is the key. Decryption is the other half of the magic trick. It's the process of using that one specific key to unscramble the gibberish ciphertext and turn it back into your original message. No key, no access. It's as simple as that. You know, this locked box analogy is absolutely perfect. Your data is the valuable message you put inside. Encryption is what locks the box shut. So even if a thief manages to grab the whole box, it's completely useless to them. Without that key, the message inside is safe. Okay, but here's where it gets even more interesting. It turns out that not all digital keys are the same. There are actually two main ways we go about locking and unlocking these digital boxes. First up, you've got symmetric encryption. Think of this like your house key. The very same key locks the door and unlocks it. It's super fast and efficient. But it has one big problem. How do you get that key to the person who needs it without someone else intercepting it? Then you have asymmetric encryption. This is really clever. It uses two different keys that are mathematically linked, a public key that you can give to anyone, it only locks the box, and a private key that only you have, which is the only key that can unlock it. It might be a little slower, but it completely solves that problem of sharing the key. And just so you know, this isn't some abstract theory. These are the workhorses of the modern internet. You've probably seen names like AES, that's a super strong symmetric system, and RSA, which is a classic asymmetric system that's often used to safely swap the keys for systems like AES. Now, there's another term you might have heard in the cybersecurity world, hashing. It gets confused with encryption all the time, but they are built for two totally different jobs, and understanding the difference is really important. The key thing to remember about hashing is that it's a one-way street. You feed data into a hashing algorithm, and it spits out a unique fingerprint, called a hash. But there is no way to turn that hash back into the original data. It's a permanent transformation. So let's put them side by side. Encryption is reversible because you need to get that original data back, right? Hashing is irreversible because you don't. Its whole purpose is just to verify something. For example, a website can store a hash of your password. When you log in, they just hash what you typed and see if it matches. They never need to know or store your actual password. Pretty neat, huh? So, why does all this techie stuff matter to you? Well, because you are using these incredibly powerful systems probably thousands of times a day, and you might not even know it. Every single time you go to a secure website, one that starts with HTTPS, that's encryption at work. When you log into your bank, send a message on WhatsApp, check your email, pull a file from the cloud, it is all being protected by encryption. And the easiest way to spot it? Look for that little padlock icon up in your browser's address bar. That's your visual proof that a secure, encrypted connection is keeping you safe. At the end of the day, that's what this is all about. Encryption gives you confidentiality, meaning only the right people can see your stuff. It ensures integrity, so you know your information hasn't been messed with. And when you put those two together, you get the trust we all need to actually use the internet. So if you walk away with anything, let it be these three things. 1. Encryption is what turns your private data from an open book into a locked box. 2. It is an absolutely essential pillar of all modern cybersecurity. And 3. You rely on it every single day.
And that brings us to one final thought. The digital locks and keys we use today are incredibly powerful. But new technologies like quantum computing are on the horizon, and they're going to bring brand new challenges and threats. It really makes you wonder, what will the lock and key of tomorrow need to look like to keep our secrets safe?